ఉంది కాదు.
Yes, ma'am. Shall we, ma'am?
Good evening to all.
Yes, sir. Good evening.
Good evening, Sabhapati sir.
Yes, sir. Good evening, sir. Good evening, sir.
Sir, can you hear me, sir?
Yes, sir. Audible.
Okay, sir. Okay, sir. Good evening to all. Good evening to all the participants. Welcome to the 6 days faculty development program on innovative teaching in machine learning trends and technologies. Okay. So day one, I welcome Dr. V. Sabhabadi for giving the lecture on introduction to machine learning. So now I will introduce Dr. V. Sabhabadi. So Dr. V. Sabhabadi is associate professor in the Department of Computer Science and Engineering Department at Welltech, iTech, Dr. Rangarajan, Dr. Sakunthala Engineering College. So he's a dedicated academician and a researcher with over a decade of experience in the field of computer science and engineering. So he holds a PhD degree in computer science from SRM University in 2002 and a MTech and a BTech from Welltech University. His research expertise lies at the intersection of technology and human behavior with a primary focus on cognitive systems, human psychology, and decision-making systems. Throughout his career, Dr. Sabhabadi has contributed significantly to the research community through numerous international conference presentations and publications in indexed journals, particularly in areas such as psychological healthcare systems, smart city development, and edge analytics. So currently serving at Welltech iTech, Dr. Rangarajan Sakunthala Engineering College. So he is actively involved in multidisciplinary research aimed at societal welfare, including projects in rehabilitation and de-addiction systems. Beyond his research, he has a strong background in technical training, having served as trainer for Java and C programming for nearly a decade. So I welcome Dr. V. Sabhabadi for this FDP, sir.
Yes, sir.
Welcome,
Very
sir.
good evening, sir. Yes, sir. Yes, sir.
Welcome, sir.
Thank you so much, sir.
We can start the session, sir.
Yes. Very good evening, one and a half participants who are all joined here. It's really happy. I feel great pleasure to share my skills, share my experience over the machine learning things. So, can I share my screen so that I can proceed further? My screen is visible.
Sir.
Yes, ma'am. Yes, ma'am. Yes, ma'am. And this is Sabhabadi. Today we can see about introduction on machine learning. What are the main objectives we can discuss today is what is the origin of AI ML and what is machine learning, and what are the basic difference between traditional programming and machine learning, and another terminologies, anatomy of ML, and what are the major research areas should be covered in this things, and types, some of cheat sheets.
Sir,
Yes, Professor.
hello.
Yes, Professor.
Yeah. Sir, sorry for interruption, sir. That slide is not visible, sir.
One second.
Yeah.
Hello, sir.
Yes, sir.
Sabhabadi,
Yes,
sir.
sir. Yes, sir.
அந்த ஷேர் விண்டோன்னு ஒரு ஆப்ஷன் இருக்கு சார், அதை செலக்ட் பண்ணீங்க. அந்த செலக்ட் பண்ணிட்டு அந்த பிபிடி ஓபன் பண்ணதை செலக்ட் பண்ணி வந்துடும்.
One second, sir. Now it is visible, sir?
Yes,
Yes,
sir.
sir. Now visible, sir.
Yes. Sorry. So these are the major things. Origin of AI, ML, machine learning, and what are the difference between traditional programming and machine learning programming, and basic terminology or anatomy of machine learning. what are the major research areas should be covered, and types, some cheat sheets, and academic evaluation based examples in machine learning, some real-time applications, and small hands-on practice today. So we can start proceed things. First and foremost, the origin of AAML. The question is started by Mr. Alan Turing. In 1950s, he only started the question like, can machines think? Is it possible? How the machine can think? Those kind of questions are origin. That's the point the work is started. And actually, machine learning currently boom and AI, those things. But it's started around almost 1950s. Actually, in 1952, Samuel's Arthur Levels, he only made a first basic like chess like games. How the moves are move. For example, if I start some initiate some moves, then automatically how the another skills. Once again. So checkers like a game, so like chess games, how the initially we predicts and our moves, those kind of things are started when the things. And Samuel Arthur stated that weights and features, if we analyze, we can make better predictions. And similarly, for that support, Newells and Simons, they provide some sort of heuristics and general problem solver logics. The main thing is the machine learning, it's a field of AI that creates models which are capable of making accurate predictions, decisions, or patterns without being explicitly programmed. In simple terminology, a model we can make a decision or predictions from the past data without explicit programming. For example, the AI and machine learning, these things and all, how artificially evolved the machine can learn. Actually, machine learning is nothing but it's a subset of artificial intelligence. Generally, right now we are using all the AIs like ChatGPT and other AIs, but inside the logic is machine learning only. The ChatGPT, for example, why machine need to think those things we'll discuss now. Machine can take better decisions in more complex, repetitive, and dangerous tasks. More complex means, for example, route optimization. Take the route optimization. Which one is traffic? Suppose if we take very traffic congestion areas, if we give the things, the Gmaps and everything, it's giving the predictions through the machine learning adaptive things. And repetitive, for example, 24/7 customer chatbot is there. So whenever we asking some sort of questions, the chatbot is going to respond instead of human works. So that's an important things. And moreover, the dangerous task, wherever the automatic drone attack, for example, recently the Sindhura operations, how the attacks are happens and how our drone is, our mission is getting identify those kind of things. So these are the things are highly essential part. So for this, the machine need to be think and it should be, work better. So for example, Xiaomi smartphone factory in China, it produces smartphone every 3 seconds. Just imagine, every 3 seconds it's produce one smartphone. It shows all kind of informations and it shows very precise and very particular about the things. For example, we assume that suppose if the human, if it is makes, it is really tough, or it may misconsistency. If smartphone productions or any other productions without human beings, without machines, if we make, there is a that is a human nature, right? So whenever there is a possibilities, the machines can make the repetitive task better than human beings. So that's what all the companies are trying. That's what the mission, since the company right now, all the industries are looking for very quality and consistent way of product development, right? So such a way, machine learning is highly useful. And moreover, they use Delta robots. Actually, it is extreme speed and pick and place. So for that reason, machine need to think very important. Then how a machine can learn? It's just mimic the humans. For example, just see the picture. There is a kid which can learn by day based on the experience. But at the same times, the machine, which can also learn, right? The robots and all the things, how they learning actually. We needed to feed the experience. Actually, machines understands only the numbers, right? It is a binary numbers only it going to understand, 0 or 1. But so that we can create or we can give the experience through the numbers, give the data. Based on the data, which can learn. That is the important basic logic behind the machine learning. If we get the informations, actually day by day we are evolving with our experience. Similarly, machine also can learn and by the data. Generally, artificial products and artificial intelligence, modern AI, what are the important concerns or important observation we need to do? For example, let's check it out, the televisions. The television, DTH, those kind of things, which provides only the fixed way of channel telecast. It's a fixed rule. If I give some sort of numbers, 512, it's going to generate only it's going to telecast the Star Sports or something. But at the same time, so you ask in Netflix or any other artificial intelligence things, the machine learning adaptive systems, which going to learn our experience and try to engaging continuously, so that only we are highly interested on Netflix and other things rather than simple television, right? So ChatGPT is nothing but it's a generative pre-trained transformer. Why does, for example, why does ChatGPT continuously ask you questions? For example, after your request and response also, it going to ask you, can I do something else? Can I do further? Why it is asking actually? The reason is for understanding, for getting the knowledge, for getting the data. If it is day by day, it has huge thrust on data. So that only, even if you are asking millions of questions, it's going to ask, still it will ask, can I do further? Since it is actually learning. Actually, it is observing, learning, and responding. So that only it is intelligence. The artificial products are, okay, it is a products, but intelligence means whenever the things are getting observing, learning, and responding, then it is intelligence, right? For example, if you take even a police cop, dogs, and those things are of detective systems, it is observing, learn something, and responding, right? So whenever the system's getting adaptive and personalized response, if it shows, then it is a artificial intelligence, right? This is the basic difference why intelligence evolved from artificial things. So whenever actually ChatGPT generative pre-trained transformer is kind of machine learning. The generative things are AI products. For example, let's see Netflix adaptive machine learning. Actually, in 2026, Netflix have a very high move. The reason is, reason behind is, it's not a just show your movies alone. It acts like a personal assistant that gets to know your personality better with every click. It is actually digital detective, content-based filtering. For example, if your kids play Netflix, which going to show some sort of Pogo or kids-based recommendations, movies and other things. And if you are adults, make same kind of things. So it is actually observing and keep on engaging you. So that and all adaptive machine learning things. And moreover, which provides context awareness. For example, even the Saturday night, what kind of informations, and even when you observe, when you consume the televisions, it's going to analyze much more. So based on the contextual data, it's going to analyze and it's going to recommend you. So the wherever the machine learning or recommendations comes, there is actually in background, there is adaptive machine learning is there. And second, sir, it is full screen actually.
Yes, sir.
Yes, sir.
Now minimize it, sir.
Yes.
Now okay, sir.
Yes. So that's what actually ML observation on Netflix, for example, it is high interest in this specific DNA. Actually, machine learning learns and adds more of this niche to your top row. For example, if your kids seeing the Netflix, it's going to show all kind of informations or all kind of the kids liking things. And similarly, This is a part of, suppose if you are fast forwarding some sort of informations, then automatically, for example, in YouTube and all the things, if you are fast forwarding some sort of things, then automatically it's going to avoid those kind of things, since it is a boring. So it will assume that the user is getting bored. So which can recommend some other interesting area. And suppose if you are searching for some sort of actors, if you are give some sort of keywords, Tom Cruise or something, if you are giving, then it going to entire filmography of the moves in your feed. So even the title also, the different thumbnail, it's daily it's getting updating, right? So that's the reason 80% of what people watching in the recommendation system engines, which can make economic for on Netflix. So backend, there is a machine learning. Next important thing is, what is the difference between traditional programming and machine learning? Better we can go with the traditional programming, right? C, C++. Why we can go for machine learning? Actually there is some important concerns or some important things are there. Since the traditional programmings, the rules are very static. The rules are very fixed. For example, see in the right side, there is a program. If I give initiate the values or variables, and if I give some sort of conditions, if it is condition satisfied, it's going to proceed something, or else it's going to proceed something else, right? But in machine learning approach, it's actually we are going to give data as well as results. What actually there and what is our expectation, both the things are we are going to give as an input. Then the computation part, the black box, it's going to make some rules adapting. It's learn and updating the rules. It's not a static. It's going to dynamically consume what the based on actual data and what's the target data. It's combinedly use some sort of statistical and other mathematical logics. It continuously learn, then it's adapting the rules, so that only each and every time if you are asking some sort of information in ChatGPT and other AI toolbox, it's going to refresh the things, right? For example, if you ask what is machine learning, could you give me some sort of examples? If you are asking ChatGPT, first time it gives us some sort of information, and next time if you are asking same questions, but it's going to again it gets adapted, it's learned, it's updated. So that's a interesting part in the machine learning. And basic anatomy. What are the important terminologies we have to know in this? If you are observing the machine learning, first of all, the building blocks. Building blocks is nothing but how we can organize our information in machine learning. So that's a part. For example, data sets. Entire collection of information. It's kind of table or spreadsheets or any CSV files. We can data sets and features. What are the columns or attribution of to make a predictions? For example, each columns of the things, each attributes we can call as a feature. For example, if pen is the object, then height and color of the pen might be the feature. That's attributes, right? Those things and all call feature things. And target or label with the specified trying to predict. We can see in an upcoming things. Okay, observation, a single data point. Let's see what is the observation means. If any point, if it is makes some sort of anomaly or abnormal things, then it is an observation point, whereas the results are getting high or not. Those kind of things are learning. And second important thing is learning phase. First we are giving to data, and next learning phase. What are the important things are there? One is training, get smart. How the model get actually learn smarts, right? That's how. Whenever you ask some sort of information, actually first time if you are asking what is machine learning, the machine learn something, and next time if you are asking, it will going to again get smart. Whenever the learning happen, whenever the training and information inference happens, it automatically gives the better things. And inference is nothing but trained model to predict outcomes on news data it never seen before. New data means actually it is testing during testing times. Training time actually generally if you take 100% of data sets, among 80% you can kept in 70 to 80% for training purpose, and 20% we can use for the testing things. So that is never seen before. It means it's nothing but the during the testing time, what kind of the output you get, those things. And loss functions, how wrong it is. Suppose actually it's minimize the loss. If you ask some information or if you ask some questions to ChatGPT, first it's going to give some sort of information. If you are not satisfying, it's again try to reduce the things, and it again make some precise values. If the user getting, until the user getting satisfied, it keep on learning, and it's keep on giving the things, and it try to minimize the loss. That means is errors. That's a thing. And optimization is nothing but it's a process of tweaking the model into the systems to reduce the things. So nothing but it's a internal variables we can optimize. If you give some sort of keywords, it try to resets, and it'll try to find the best answer from this. And third important thing is evaluations. How we can know actually ML is good. Suppose if you assume that you are building some sort of machine learning model, we need to test, right? We need to evaluate. Actually, it's a kind of report card. So how accurately it finding the predictions. This misleading, if it is unbalanced, means we can understand, and we can bootstrap or back propagation we can do again and again till the accuracy level come. And next important point is important concept is called overfitting. For example, if it is too smart for its own good, for example, assume that there is some sort of our in academic way, some sort of students are actually academically very good, since they are memorizing the content, they will deliver in the exams, but they are sometimes it fails into the new data. Suppose if it is a HR or during the placement rounds, if it is comes, they are like overfitting, since the informations are too good, but some sort of training or some sort of misleading might be reason to get negative things, right? So that is what they are too smart. Instead of understanding, they are just memorizing contents. Then those kind of concerns will come into the overfitting. And next one is underfitting. When the model is too simple, even to learn the basic patterns, there is a very limited models or very limited data set if you are given, but if you try to find the best answer from it, it won't respond for it. So those kind of things are very underfitting. For example, the students who are all regularly absent, and if you ask some sort of, if you expect a 90% result, it might be a little tough task, right? So since the basic things are very limited, so the train and test split, generally 80% of training data set and 20% we can make it as exams. And finally, the important thing is key method. What are the logics? How we can make those kind of things are really important. Algorithms to set the recipe to find the patterns. For example, what are the whenever you're going to make some sort of rules, if you define the rules, for example, if you want to make some sort of recipe, what other rules are there? If you put first water and salts and those kind of informations, if you are keep on building, so if you providing some sort of rules, then it is try to find the patterns, best patterns from you. Then model is nothing but the engine produced after the algorithm is finished. For example, if you give some sort of basic algorithm to your model, then model going to repetitively do the things. It repeatedly understanding things, then model get executed in each and every times, unless if you are going to change any parameters or hyperparameters. Parameters are nothing but internal variables. You need to just change the things. Then hyperparameters is try to choose before training starts. How model it get fast learn, till that you can make hyperparameters adjusting. So next important thing is, what are the different steps involved in machine learning. One is collecting data. Kaggle or you say any repository, if you are trying to predict some sort of any disease predictions or any stock price predictions, what kind of data you want for your problems, you have to collect from the repository. And next thing is, you need to preparing the data. What do you mean by preparing data is nothing but for example, if you assume that you are going to take a census or some sort of sampling, in our area who are all having tumors and other problems. So in this particular context, you don't need to worry about what their address and what their phone number and other things and all. You need the patient, what is the response for that. So you need to avoid what are the maximum unnecessary content for your context. Since each and every large data sets, it's a very big concern. So we can't make load in the GPU and other things. Better we can pre-processing. If you are working, then it is called preparing the data. And next one is choosing a model. What kind of model for better things? For actually each and everything have separate kind of models we can discuss in further. And once you choose the model for your project problems, then you can go for training. Once the training data sets, if it is getting trained well, then you can make evaluation. Evaluation is nothing but how to accurate and F1 recall, other things you need to check it out. And next one is hyperparametric tuning. That means it's nothing. Internal variables you can change based till your goal is achieved. So then it is called hyperparameter tuning. And predictions, it's how accurately predict. Around 99% if you are predicted, that is also still a thing. So we need to make it out. For example, how we discussed the steps, right? So next we can discuss in the examples. For example, you just assume that if you give the input of some actor images as a machine learning model, and it's actually your machine learning going to learn what you are giving the input as a images. So CNN algorithm or other image processing algorithms going to learn from your data. So it's look like one actor. Yeah, and it's building the logical model is going to build, and assume that in this is the training data. During training data, you are giving 80% of real-time data and repository data. And during the building model, once you build the model, if you give for the testing purpose, if you give some other model, some other image, then if you ask some set of questions, it's going to say, if we ask this is this Shahrukh, likewise if you ask, it's going to classify no, right? So this is a basic machine learning things. Since it's learned from your past data, how much data you are giving, till that it learn, keep on engaging the things, and what kind of perspectives, what kind of features this first image have, the face and each and every knock, it will try to find the patterns. If once identify the entire patterns, if your model, you think your model is highly accurate, then if you are going to give a testing data, during the time it should say no. How effectively it says no. If you change even some modification in the input image also, it's going to accurately predict or not. That's an important concern. So example analogy, for example, just what kind of algorithm actually, for example, backing equivalent like recipe. If you give some sort of step-by-step instructions, mix flour and eggs and those kind of what are the conditions, if you are make the cake logic, then it is called algorithm. And model is nothing but the finished cake. Actually result you get or use, then recipe after has been combined. So once you entirely give the your model is highly accurate, your thing is over, then it is called model. The parameter is nothing but it's an internal texture, internal state that changed while it was its oven. So you can adjust your internal things till you are suppose if you are not getting that much accuracy, then you can make your internal texture and as well as hyperparameters. So these are the things are example for things. And next one is machine learning vital components. Actually, there are three important things you need to taking care of. One is task. Task is nothing but you just assign a responsibility, your model, whether it is a Shah Rukh Khan or not, those kind of things, right? That is even example, spam or non-spam or any classification or any regression form of things. You first you're going to assign a task. Next important thing is experience. Experience is nothing but have to give the data. If you give images of Shah Rukh Khan, that means the machine getting experience. Oh, is the Shah Rukh Khan? He look like this. He look like this. Likewise, it's going to add his own experience. And finally, performance evaluations. How many accurately finding while testing some other image, whether it is predict or not. That is the important point. So if it is predict, then your model is really good. So these three concern you always keep it in mind. These three things should be in your machine learning. Next, we'll discuss about machine learning examples through our paper evaluation on our as an academician. We can learn something about the types and examples. What do you mean by supervised machine? There are majorly three important supervised machine learning is there. One is supervised machine learning, and another is unsupervised, and third one is reinforcement. Assume that what do you mean by supervised machine learning? If it is a label is already there, based on label, if you are taking decisions, then it is called supervised learning. Example, you have an answer key. Based on answer key, if you are evaluating the paper, then you are taking supervised learning. That means the answer key act as a label. Based on the, for example, part A questions, so and so keyword, if it is there, then only you're going to give allocate the marks as 2 marks. If it is part B, if you have some sort of keywords, then only you're going to give that full marks, right? Then that is a supervised learning. Since you are taking decision based on the label, the answer key, it's act as a label. So that is a supervised machine learning. And another one is unsupervised machine learning. For example, without any labels, you just try to find out the pattern of the paper. Handwritten is right. If he perform his presentation was too good, then automatically without answer key, without any checking, if you are going for evaluations, then it is kind of unsupervised machine learning. That means which is going to discover the hidden patterns alone. That's important. Without any label, if you are going for some sort of prediction, or if you are going to clustering, or if you are going to grouping some sort of information based on your heuristics, then it is called unsupervised machine learning. And third one is reinforcement learning, trial and error based method. For example, you're just going to evaluate the paper without saying any answer key and other things. And once you verify, once you give the marks, then you are seeing the answer is mismatch. Actually, what you'll do, you won't do the existing already done. Hereafter, you'll change the things, right? So likewise, till that trial and error, if you are making your choices and you are going to decisions, then it is called reinforcement. Reinforcement, nothing but you re-experience the systems. You learn the, actually you forcibly you are going to learn based on the trial and error method. If you are making it good, you just follow. If it is wrong, you correct it, right? So that is what reinforcement learning. Right now, the reinforcement learning is highly populated. So, for example, there are numerous set of categories are there. So we can see what are the example algorithm over there and what is the real world use. Those kind of things we can discuss. Yes, same. Supervised learning is nothing but labeled data where answer is already known. If you have answer key, if you are giving the marks, then it is a supervised learning. For that, random forest, XGBoost, SVM, support vector machines. These are the example algorithms in supervised learning. In spam detection, for example, in your email, these are the things are spam. These are things are non-spam. How the machine getting learned? Through the spam detections only. Actually, your Gmail is better performing actually. Unless the spam detections, you can't filter out your important mails from your Gmail, right? So those things are applications of supervised learning. And unsupervised learning, hidden patterns. For that, there are 2 example algorithms are there. K-means and clustering, K-means clustering, PCA, principal component analysis, those kind of things and all come under the unsupervised learning. Customer segmentation, it's a real world use. For example, assume that you had a supermarket in that who are all going to buy some sort of, for example, our amount 10,000 worth of product in purchase in every month, who are all having 1 lakh purchase. So if you're going to segment the things, then you can going to analyze the pattern of the customer, right? Instead of things, you have to identify the pattern. So then it is a unsupervised learning. And reinforcement learning is a self-driving car or game or chess, those kind of things and all come under the reinforcement learning. The Q learning and deep Q networks are example of algorithm in things. And next important thing is self-supervised learning, the transformers. Right now, the generative pre-trained transformer, GPT, ChatGPT, and BERT, those kind of things and all, NLP, generally textual data, large language models, you're going to use self-supervised learning and much more. And semi-supervised learning is nothing but small amount of labeled data as well as a huge amount of unlabeled data. If you combinedly, if you are working, then it is called semi-supervised learning. Actually, label propagation, self-learning, those kind of example algorithm. So what are the major machine learning related areas should be covered? Actually, if you're writing ML related research papers, so these are the points are highly important. You should share a clear problem statement. What is the important task you have? Either spam filtering or any other tumor detections or any other image detections, then you need to assign the task. That is a first point. You keep it in mind. Next thing is, are you improving? Actually, in the first point, are you improving the accuracy, and you have some sort of justification with that, making model faster or efficiency, or if you're solving new problem has not been automated before. So these are the important points you need to keep it in mind. So once you clearly define your problems, then you'll go for data set descriptions. Actually, source where you come from, where you collect the data sets, either Kaggle or real-time data sets where you collected, those kind of things are highly important. And next one is number of samples you need to give. How many rows and for example, how many columns and how many rows you are taking for features, and pre-processing and outliers, those kind of things, and splits. Pre-processing is nothing but if you're handling any missing values, how you overcome the things, how you reduce the noise. Those kind of pre-processing the data is pre-processing, and split the how many you are going to split the training and validation purpose or testing purpose. So these are the 4 important points you need to note in the description phase. And methodology, you need to show some sort of algorithm choice. Why you are picking random forest or any other or neural network, or you need some sort of convinced justifications. If you use architecture, for example, if you use deep learning, then it's a diagram of the layers, all the things you need to show it, and hyperparameters, list your learning rate, batch size, epochs, and other things you need to learn. You need to mention it. And loss functions. What was the model trying to minimize? Mean square error or absolute mean square error. So based on literature review, we can make it out. And next important point, how can we make pick a model? Actually, there is a theorem is called no free lunch theorem. That means no single model fit for all. That's an important point. Equally, we can't say that is not a right way to do things. So based on shape of your problems, you need to assign the tasks. Actually, most probably, the 3 important classifications will come. If you want to predict a label, you have to classification you can use. If you want to predict continuous numbers, regressions, for example, the stock price, or next month, what is the gold rate, right? Now, versus the important point, the gold rate is daily, it's getting ups and downs. How we can predict? Last 20 years data or last 2-month data. If you feeding the data to your systems, it going to predict by next month, February 30, what will be the or February 28, right? March 1st or those things, next month or next month, what will be the expected stock price or gold price? We can predict through the regression models, continuous numbers. If it is continuous numbers, you can go for regressions. And next one is, you don't have clustering. Whenever if you want to customer segmentation and those kind of things, you're going to use clustering things. And other results and discussions, graphs, visuals, and reproducibility of code. These things and all you need to add in your research papers. This is a machine learning model cheat sheets. Why it is actually, if you have some sort of problems, most of the problem you can it will be classified in this way. For example, if you have classification problems, then random forest or XGBoost you can deal with it. And if you have linear regressions, then you can use tabular or Excel. If it is a classified things, categorical variables, then you will go for classification. Or if it is real-time stock predictions or gold price, you can make use of regressions. Linear regression or ridge regressions are example models of our regression types. Random forest and XGBoost for classification purpose. And next one important thing is images. Suppose assume that if you got a image related classifications, then we can use for generally we can use CNN and other types. It designed to recognize the spatial patterns. So that's where we can use. And whenever the text or sentimental analysis or review analysis, during that time, you can go to use predictions through transformers. But GPT, ChatGPT, those kind of things and all transformer recommender models understand the context and along long range things we will do. And next one is simple patterns, the grouping, those kind of things you can make use of k-means algorithms. Evaluation metrics, classifications and regressions baselines are there. So consider constraints. If you ask 3 questions, how much data you have? If you have very less than 1,000, then you'll go for linear regression generally. And deep learning will likely overfit for these kind of things. And do you need to explain why? If you you know that the bank why denies the loans, the reason is begins there is a decision tree will be there. It try to understand what kind of your whole history, and it will take a decision. So whenever you're going to make some sort of informations, the decision tree or machine learning algorithm going to detect the base, try to predict or try to describe your values. For example, if you're using credit card, if your credit history was very good, the next year the banking going to enhance your limit, right? Which is happens through decision trees. It will read and understand your how you are paying on times. Those kind of informations are learned by machine learning. And what is your hardware or logistic regressions? Those kind of things are right now large LLMs are used in GPUs and other things. So these are the 3 things we can use it. And generally AI tools elicits consensus. For example, these are the tools are machine learning working, and as well as AI tools, which is going to highly useful in the research. One is elicit. This is highly useful for literature review. And next one is consensus. It is search engine. It will going to give a lot of literature reviews, and it give lot of information about the papers and all the things. And Cite AI, it is going to provide a citation audit. Verify your paper it is reliable. If you have any literature reviews, if you are audit in the Cite AI, which is going to give some sort of whether you referred correct citation or not, those kind of information is going to give better. And research rabbit, which is discovering mapping the new field of study. For example, if you are giving some sort of abstract, it's going to suggest you better. Those kind of suggestions will give through the research rabbit. And PaperPal, these are the things are highly useful for initial state of writing. But my suggestion is take AI as a your supporting assistant. You need to consume the data first. You can consume data and you can make it your own. Since all the same no free lunch theorem, no models is common for all. So all the information is not for you, right? The ChatGPT or other machine learning things, AI tools, which whatever if you are asking questions, it gives lot of information to you. Sometimes it mislead you. So during the time you need to analyze by yourself and you need to understand, and that's where you need to work on it. If you That's where you can make a create research papers. And case study applications, the finance, especially XGBoost, they are using. In the finance applications, the real-time fraud detections, PayPal actually last year, $4 billion is drastically reduced false positives who are all unpaid. Those people are, the finance industries are highly used to XGBoost and Random Forest. They predicting and try to make a better bank. And healthcare, early cancer, tumor detections, where 25 to 40% reductions in diagnostic errors are made through the CNNs. So CNNs providing better predictions, which is highly helpful for human health diagnostics or medical experts. And retail industry, the personalized recommendation like Netflix and Amazon, it gets around 80% of revenue from the retail industries through the machine learning adaptive things. And education, reinforcement learning, highly 70% of boost in course completion, content adapts in real-time students' logic gaps. So adapting learning paths, Duolingo, Coursera, these are the courses are highly using the reinforced learning, which is once you once you get the good marks in particular subjects, then Coursera again going to teach you or recommend to you take another course related to the particular domains. So these are the things and all happen through automatically through the adaptive machine learning. So it is very highly impact in the all other roles in many more. What we given it's very limited. So my suggestion is try to learn a lot of just try to observe many recommendation systems where you can find what is the basics, what is the rules in behind it. If you analyze, they can use this kind of informations. So the teachable machine learning, you can if possible, just take a teachable machine. We can do simple hands-on things. If you go to teachable machine with Google, you just listen the things, and after the things after the session, you can check it out. Teachable machine, just note down. I'm giving a new project. It's actually Google product. If you click new image project, we can give class 1. We can edit actually. For example, without specs, I'm giving my loads. Then I just close it. Next, I'm going to with the specs. Just I'm making images. See, I'm taking with the specs, without specs. I just hold on, and I make the both the data sets, and I'm going to train the model first. Sorry, screen is not visible. Is it visible or not? Okay.
சார் இல்ல சார் விசிபிள் இல்ல. அந்த அந்த இப்ப ஷேரிங்ல போயிட்டு அந்த விண்டோ செலக்ட் பண்ணி எந்த ஸ்கிரீன்ல ஒர்க் பண்றீங்களோ அதை செலக்ட் பண்ணுங்க.
ஓகே ஓகே ஓகே
விண்டோ
ஓகே
விண்டோ அந்த வெப். ஓகே ஓகே.
Okay, let you Actually, I take a screenshot. I can show right now. You can after the session you can try with this. Okay. Actually, if you go to teachable machine learning machine, you just go it enter in the things, and class 1 there is a two for example there is 2 tests you can make it out. In class 1 we can make a with the specs one class we can make, and another class we can make a without specs. Then if you give the training middle of the portions, then you can, once you test the things, it will show the things. If you use without specs, it will going to make 1 second. Mm.
சார் இது இந்த பிபிடி இருக்குல்ல சார், இதை ஸ்டாப் ஷேரிங் கொடுத்துட்டு
Okay. 1 second.
அப்புறம் அந்த திரும்ப போய் ஷேரிங்ல போயிட்டு அந்த விண்டோஸ்ல செலக்ட் பண்ணி அந்த அந்த வெப் பேஜ்
Okay,
ஓபன் செலக்ட் பண்ணி.
Okay, sir. Okay, sir. Okay. Now visible, sir?
சூப்பர் சார். yes sir,
Yes.
சூப்பர் சார். சூப்பர் சார்.
Yes. Just go to teachable machine. I give with the specs. I just make without specs. I give the data sets. Next, I call it, and next I make a with the specs. With the specs, it's taking images, and both the data sets are given, and now I am training the data sets. If I remove this, then it shows in down, it shows without specs is 100%. If I put specs, it shows with the specs, right? Hope you understand what I'm trying to convey. Yes, sir. So that's what the thing machine learning is. So teachable machine, there are numerous things are there. You can try with the audio, and even you can try with the poster texture also. You can check it out. So it's a better thing you to learn about the machine learning and things. Okay. And second. So these are the certificate courses you can refer for. Sir, this is. Are you getting actually this page? Can I share actually?
ஸ்டாப் ஷேரிங் போட்டுருங்க சார். இதை அப்புறம் திரும்ப அந்த இது பண்றேன்.
So these are the machine learning things, and my suggestion is, my recommendation is to learn about this kind of certificate courses. Actually, Google giving some sort of free courses. Google Developers ML Crash Course, and that is free. That is good. And another one is financial aid Coursera courses, also machine learning in specialization. Those courses are highly impact. And my personal interest is in machine learning engineering, delivered by Balaji Srinivasan in NPTEL course. You just check it out whenever you get the free times. And these are the both reference important books. One is Ian Goodfellow, and another one is Tom Mitchell. You just whenever you get the times, just go through these two Bibles. I highly recommending these books, which gives actually it is a old versions, but it is really good. So that's what today I hope I try to give my best. So it's thank you so much.
Thank you, sir. Thank you, Sabhabadi, sir. Really very resourceful, sir. And
Thank you
you
so
have shown
much.
this hands-on. That is
Yes,
very
sir.
excellent, sir. Real
Thank
time
you
you
so
have
much, sir.
shown. Thank you, sir.
Thank you so much.
Sir,
Sir. Thank you so much.
sir, participants, if you have any doubts or any queries,
Yeah.
you can ask
Yeah.
Dr. Sabhabadi.
Yes, sir. I'm happy to share my what I learned something. But yeah, it's really
Sir, good evening, sir.
yes, sir.
Sir, this is Dinaran from CIT College.
Yes, sir.
Sir, how can we improve the accuracy, sir?
Sir. Yes, sir. Yes, sir. Can I? Yes, sir. Sir, accuracy. We can train the. For example, once you adjusting the values, the hyperparameters, pruning, and backpropagations are a lot of actually based on your context. What kind of algorithm you are using? From that, the internal hyperparameters tuning. It's the only important thing, sir. Better you can check out the literature reviews and what kind of for example, regressions and classifications based on your prediction or description based, the hyperparametric approaches are different. So you can change internal values, data sets. For example, you try to reduce the data sets from, for example, you try to reduce the where the noisy happens. You just try to find, sir, first and foremost. For example, if you have many outliers or if it is not related to your particular context. For example, you just want to category the only is this dog or cat. Then you take the particular attributes in the highly impact in the context. You don't try to avoid if you avoid unnecessary noise, then you can get a better value. It kind of hyperparameters. You can make use of regularization. And another important thing is try to use TensorFlow background. TensorFlow, actually there is a website is called TensorFlow background, TensorFlow simulator. You just check it out, sir. Which going to give very important things. And if you give some sort of information, or if you're going to give your training data feed, you can hyperparametric we can do in the online simulation itself. It will give a better suggestion also. So my suggestion is try to find out data sets onwards, sir. Dinagar, sir, actually based on problems, you can you need to change, sir. It is either classification or description problems or regression problem. What kind of algorithm is this? And based on that, you need to work on, sir.
Okay, sir. Thank you, sir.
Thank you so much, sir. Yes, sir.
Thank you very much, sir. Thank you, sir.
Thank you so much. Yes, sir. Thank you so much. Great pleasure, sir.
Thank you, sir.
Yes, ma'am. Thanks, ma'am.
So I have posted the feedback form. So all the participants fill the feedback form. So it is in the
Yes,
chat box.
Yes, ma'am. Thank you, ma'am. Thank you, Priya, ma'am, and thank you, one of you. If you have any doubts, you can. I try to sort out. My mail ID is I shared with sir. If it is any doubt, we can get back. Sabhabadi@velgaitai.com.
Sir, can you
my-
please share? So sorry for
yes,
disturbing.
sir.
Sir, can you please share
Yes, sir.
this?
Yes, sir.
Actually, I'm a
PPT, yes,
professor
sir.
in engineering college, sir. I'm handling
Sure, sir. I
artificial.
share. Salon, sir.
Yes, sir. Can you please share this PPT? That's enough for me, sir. For from the next day, I'm going to
Yes, sir.
explain your concept, sir. Yes, sir.
Yes,
can
sir.
you
Thank
able
you
to
so
get
much.
my-
Sure, sir. Sure, sir. I'll share it.
Oh, okay, sir. Okay, sir. Actually, the sir sent it one feedback.
Yes, sir.
Not able to get it. Sir,
Sir, feedback not yet came, sir, till now.
Sir, feedback, I think you are not posting any feedback.
This is the chat box, ma'am.
Sir, it
Chat-
is not
The chat
visible.
box
Sir.
I
We
saw,
are
Go to
sir,
the-
already.
in the chat box, sir. We are
Sir,
in the
chat box
chat box, but still now we didn't receive. Please kindly repost that, sir.
Okay.
Sir, it is not in the
Sir,
chat
chat
box.
box is not opening, sir.
Can you please share it again, sir? It's not in the chat box also.
The chat box also not available, sir.
Uh,
Hmm.
sure, I'll share in my PPTs.
Okay, sir. So I'll share in the Google group, sir.
Ma'am, please
yes, sir.
share the attendance feedback link, ma'am.
ஒரு மீட்டிங் அட்டன் பண்ணிட்டு இருக்க ஒரு 5 நிமிஷம்.
Chat box not
Ma'am, please share attendance link, ma'am.
Dear participants, I posted in the
WhatsApp group. Sir, can you post,
WhatsApp group.
if you
Please
don't
check
mind,
in
can
the
you post in the
WhatsApp
WhatsApp group, sir?
I'll post it in
Just send
the
it in
WhatsApp group.
sir. That's enough for us.
Yes, sir. I share
Yeah,
my
Okay,
sir,
PPT
I
also.
posted in WhatsApp group. Yeah. So check
Fine,
in
sir.
the
That's
WhatsApp.
fine,
Thank you, sir. Thanks, sir.
Thanks for that.
Okay, thank you.
And
Thank you,
also,
sir.
I'm waiting for your
Sabhavati,
PPT,
sir, thank you, sir.
Yes, sir. Thank you, sir. Welcome, sir.
Thank
Thank you so much, participants. I think I don't want.
Thank you for valuable sir.
Ma'am, can you post in
Yes,
chat
sir.
box,
Thank you so
ma'am,
much, sir.
again,
Welcome, sir.
please?
Fine.
Ma'am, check in the Google WhatsApp group, ma'am. Check WhatsApp group.
Sir, I am not in WhatsApp group. One second.
What I can do, ma'am? Posted in chat
Okay,
chat
sir.
box also.
Yes, sir. Yes, sir. Okay, sir.
Okay.
Okay.
Yeah, sir. Thank you, sir.
Thank you, sir. Sabhavati, sir, we can leave, sir.
Yes, sir. Thank you. Please.
Thank you.
இருக்குது. Sorry.